The next thing I'd like to talk about is how we can build a slightly more robust state machine inside Unity. So previously we talked about this click to move script where we built out our states as just these individual enums. We had an update function which essentially checked what the current state was, either idle or moving, and then called the appropriate logic based on that, do idle or do moving. Now, there's a couple downsides to something like this. One is we've built this system that's this state machine, but it's kind of hard-coded here and only functions in this click-to-move script that we have, which is totally fine for a lot of state machines. And building them like this is completely appropriate for, maybe 80% of the time or so. But eventually, you may want to build a slightly larger, more robust state machine that you can reuse in multiple places, or AI that have various numbers of states, or some AI that have 90% of the states that another one has, and this one has a couple extra ones, or things on those lines. The other thing that we definitely want is, as we are transitioning between these different states, between idle and moving, there might be logic that we want to run when we first start moving, or when we stop moving, when we transition back to idle, right? You see this a lot when you have an AI in a game who's currently like chasing the player, and then when they stop chasing the player because they do what's called a bark. They do they do that shout that's like, must have been the wind, and then they go back to patrolling, or where'd he go? And then they go back to patrolling or being idle or doing whatever they do. Now, those are little bits of logic that you just want to have execute once when you first enter a state or when you first transition out of a state. And we don't have any sort of support for that here. And one thing that we don't want to do is add the logic for entering a different state, like moving, here inside the logic of our idle state. So I'm going to suggest a couple different methods, or a couple suggestions to get you thinking about how you could build a slightly more robust state machine system. So first, let's build a mono behavior, that component that we're going to put onto our AI, which is a state machine. And this state machine is going to have a generic list of states that it could be in at any given time, as well as its current state that it's in, right? So in addition to this, let's also build a brand new class which represents our AI state. Now, we're going to use inheritance and polymorphism here as our strategy for building out new AI states that have this functionality. So when we think about what an AI state might have, it's going to have a couple things. It's going to have its update function, right? It's going to have its update function, which will probably just be like public void update. It's also going to have, it's also probably going to have some sort of logic potentially associated with it that's like a on enter state, right? Which this may be the function that contains all of the logic for what happens the first time we enter this state. And we might also have a function that's like on exit state. Now, you may also think of other times with these AI states that you may want to add individual logic to them, right? As opposed to just entering a state, exiting the state, and then what it's doing during its update. Now, in the actual state machine, it'll probably have some sort of, I don't know, potentially like a list of AI states. You just call it states. So here's a list of all the potential states that we could be in. And then you might also have something in here that's like the AI state for the current state. Now, this current state will need to be initialized to something, probably one of the states that's inside of your list of states in your state machine. And there's a couple sort of like implementation details here that I'm kind of like glazing over, just to sort of talk about the overall structure of what this finite state machine system, or what the state machine system would look like. So just like in the last version of our state machine, our update function needs to update the state that we're currently in. So that would probably look like something like this now, where we have the current state and we're just simply calling the update function on it. That's it, as easy as that. In addition, we would also want to support some sort of functionality for transitioning from one state to another. So we could say something like this, maybe. We are going to support a brand new function which could be called from any of our AI states, called transition state. And this is going to take a new state for us to transition to. And one of the things that this function is going to do is it's going to set our current state to our new state, the one that we want to transition into. But then in addition to that, now we also have the opportunity to say that we want to do the exit logic of our current state and then do the enter logic of our new state. So you can already see how this is starting to support more, different types of states and just more functionality within our state machine. So this function transitions the state machine into a new state. So what else do we need to do? Well, here in our AI state, this is a class that we would essentially use as like our base class, and we would have specific AI states that inherit from this. So if this is our base AI state, we'd probably want to build like a patrol state, a combat state, an idle state, and we want each of those to be able to implement their own functions. So these public functions here need to be abstract. Or I'm sorry, they need to be virtual. Virtual is spelled correctly. And just by making these functions virtual, any of the classes that inherit from this class can overwrite them with their own logic. So now we can create a patrol state that has its own logic where it's overriding what happens in onEnter state within its update, as well as in the onExit state. This state machine, this is the only component here which we can tie onto our game object, onto our AI agents in our game. And now we are sort of driving this more complex state machine with custom built states within it. And now instead of doing individual states where they each have their own single function, which is just like an update function, we can build completely new C# scripts that inherit from this AI state class here. They do their own enter state logic, update logic, and exit state logic. In addition to that, we can also put data within the states here so they kind of remember, when you're in combat, who your targets are, when you're following someone, or when you're pathfinding, what your path is. Any sort of data related to the individual state could live within the individual states themselves. Okay.